Hello, my name is Cindy Lopez, and today I'm going to be presenting a figure from our textbook, uh, Becker's World of the Cell, and I'm going to be explaining the synthesis of a core oligosaccharide. So before I get started on the explanation of that figure, I'm just going to go ahead and give you guys a little bit of a background of what exactly oligosaccharides are. So they are a type of carbohydrate. There are many types of oligosaccharides, some of which I've listed here. Fructo oligosaccharides, or FOS, galacto-oligosaccharides, GOS, and human milk oligosaccharides, HMOs, and many, many, many others. They're composed of a small number of monosaccharide units, usually between 3 and 10 units. And the function of oligosaccharides are cell recognition and cell adhesion. Here I present you guys a image of a oligosaccharide known as raffinose. So now I'm just gonna go ahead and walk you through the steps of how a core oligosaccharide is synthesized. This is taken from our textbook, figure 12.6. And basically what happens is that dolichol phosphate is first inserted into the endoplasmic reticulum membrane. From here, you can see on the figure that it's inside of the cytosol now. N-acetylglucosamine and mannose groups are added to the phosphate group of the dolichol phosphate. And again, this is happening in the cytosol. It continues to grow, and it keeps adding these different groups. And then finally, once it reaches a certain amount of mannose and N-acetylglucosamine, a phospholipid translocator known as flippase will take the oligosaccharide from the cytosol back into the lumen of the endoplasmic reticulum. Once it's back in the lumen of the ER, it adds more mannose and glucose units, and then the completed oligosaccharide is then transferred to an asparagine residue of the recipient protein. On this final step, the oligosaccharide is attached to a protein, trim and modified, and then sent to the Golgi apparatus. So for this presentation, there were a few questions that also needed to be answered. The first question was, what role does UDP, GDP, and dolichol phosphate play? Uridine diphosphate glucose, or UDP, is basically what carries the N-acetylglucosamine and attaches it to the dolichol phosphate group, as you kind of saw in the figure. Guanosine diphosphate, or GDP, carries mannose and attaches it to the dolichol phosphate group. And then finally, dolichol phosphate acts as the carrier of the oligosaccharide while it's going through the process of glycosylation. The second question was, what is the composition of this core oligosaccharide? Well, I went ahead and trimmed off and basically gave you guys an image here that shows you what that finished product looks like. So the finished oligosaccharide has 2 units of N-acetylglucosamine, 9 units of mannose, and 3 units of glucose. Well, that has been my presentation. Thank you guys so much for watching, and I will see you on the next one.